Okay, we got 8% battery left. So
yeah,
we got one
take.
take.
One take.
We have 1 year, and we want to try to hit as many different flavors of robots as we can.
Yeah, I mean, there's, we've mainly focused in all of the robots we've built on rover type platforms. And there's a lot more to robotics and a lot more useful forms of robots that we've never explored, we have no intuition about, and we just want to dive in and get a sense of them. So, balance bots, microbots, quadcopters. We want to make a big rover. Like, we've always done like table size type stuff. Robots that really push our boundaries of what we know how to do. We look at it, we're like, in theory, we're capable of this, but I have no idea how to actually do this. We don't just have the steps laid out in our heads.
So, on the devlog episode 1, let's get to business. We decided to build a balance bot as our first project because 1, we haven't built one before. And 2, they're mechanically really simple, especially in relation to how maneuverable they can be once they're completed. And then the third reason is that the system dynamics and controls of a balancer look really fun. This project is going to serve as a great playground for building up our fundamentals that we're going to need for the overarching project of building a wide variety of robots over this next year. Where the design is right now, we've been designing in Onshape for the CAD, 3D printing these parts that you see here, laser cutting a couple of the flatter pieces, and then mounting our circuitry on top of all of this stuff. I was really aiming to not have to modify 3D printed parts after we make them, so I added a lot of extra holes so we can mount racks of more sensors or anything else we need in the future. And then in Autodesk Fusion 360's electrical suite, we tossed together a quick PCB that I decided to try etching myself, just as a quick and dirty, see how we could get it done. I've designed a few circuit boards before, however, I've always sent them off to China to get them manufactured and then sent back, and that process takes a couple of weeks. So I decided this time I wanted to try, etching it at home myself. Grabbed a glass container from Target and threw some ferric chloride in there. And yeah, the process was pretty quick and easy, honestly. I was very happy. We used the acetone toner transfer method, as opposed to like a lot of people iron them on and stuff. Then we got to the fun part, programming. This is when we set up the Arduino framework. We were using Platform.io in VS Code, and our motor controls were using the simple FOC library, which is a fantastically documented library, has a thriving community around it, and if you need to control some brushless motors, you should go check out their repo on GitHub. After tuning the motors for velocity control, we wrapped that control loop with our own PID control loop. And then the robot fell over about 5,000 times before we realized we actually didn't put the motors into velocity control mode. And then after about 5,000 more times of it falling down, it got to this wobbly state.
What are you doing to me, balance bot?
And we kind of started to wonder if maybe we should go back to the whiteboard and do some more math. Maybe we should be fully characterizing our system, and I don't know. But we decided to keep on going, and it got a lot better. In summary, we have a robot that balances now, and we can stack some things on it, send it across the room, lead it around on a string. That's all good and dandy, but now that the proof of concept is done, we've started to do some analysis on the existing literature of balancing systems, inverted pendulums, etc. And it's clearly the case that there are a lot of ways to handle this. We're going to spend the next week or so characterizing our system and modifying parameters if needed, and testing out these different controllers that are proposed in the literature to see what kind of performance we can squeeze out of these ideas. Hopefully by the end of this, we're going to have not only a balancing robot, but one that can be controlled and steered, and also a big insight into what someone should be most concerned about if they were going to start their own balancing robot project today. Now's the part of the video where it ends, And this was our first one, so give us some feedback and we'll try to incorporate that on either the project or the video. If you like what we're doing so far, give us a follow. It'll help out a lot. And see you next time.
Let him go. Let's see what happens.
Yeah, let's see him get up this little obstacle course. Oh, God.